Can you see a web browser in a terminal?
Yes.
Okay, so can you tell me what software you are using and you would like to hear about today? So I am not expert, yes, in all the packages that are installed, of course, but I prepare some examples, yes, for the most common applications. And if you tell me which one, then we can focus on that one. Yes. So if you want to speak, then you can write in the chat so that I can see what is your preference.
Maybe just pick some of the popular ones, then if people don't have preferences.
Yeah. So I will then go through the best practices section, and then I will pick one particular applications. Uh, okay, someone said I don't have a preference. Okay, so I can pick any of them. But first of all, I will go through the best practices, and this is based on uh, the experience that I have upon working in an HPC center, right? And based on the common issues that arise, yes, when a person tries to use HPC resources, yeah, especially in the Swedish HPC systems. So here, this is specific for Kebnekaise, but it is also valid for all other clusters in Sweden. And as you can see here, it says use your project directory instead of the home directory. So when you apply for a proposal, you get a project as Birgitte mentioned previously, right? You get the project, the computing project, and also some storage space. Yeah. So one of the common mistakes or the common things that the people do is that they try to use the home directory, right, to store the data and also the scripts that they will use. But it was also mentioned before that this space is limited to 25 gigabytes. And especially if you are doing a data production or you have a large databases, then you will immediately exceed this space. I'm coming now. I close my door, yeah. And then this is why uh, you should instead use your project directory, which reads like this one, Pro no backup, and some naming related to the project type. If you didn't choose a custom name, so otherwise you will use the custom name that you choose. And this one has a much larger space, right? So the second thing that is very common, right, is that you will try to access the project folder by typing or by copying and pasting this large name, right? So for instance, if I want to go to this folder, then I copy this path in a terminal, and then I try to do a CD and then the large name, right? To avoid this situation, right, where you want to copy and paste this long name, especially if you have many subfolders in this directory, right? So you can instead create a so-called soft link, which is a shortcut as one can do in Windows, for instance, where one creates a shortcuts in the desktop, and then one can access the application or the folder at some other place. So how to do this? You go to the home directory first, and then you type on the terminal ln dash s, the project name, as you can see here, and then you choose a name, yes, related to the project or based on your choice, right? So the result will be that in your home folder you will have a shortcut with this name that then you can access uh, as it were another folder, right? But this is just a shortcut to the project folder. So for instance, in my case, I have a project folder that is called a POHPC, right? If I go to my home directory, then I can type ls-lhrt to list the files that are here. And I type this one. And you can see that this custom name points to my project folder. And then if I want to go to this folder or to my project folder, instead of typing the long name, Pro no backup POHPC, yeah, I can just type CD and POHPC, and I am there, right? So this will simplify your workflow. Okay, the next point is monitoring the resources usage. And it can happen, right, that in your batch script, because as Birgitte mentioned previously, to work with the data production, yes, it is recommended to use the batch scripts. Yes, you should use a batch script. Yeah. And then it can happen that in this batch script, you specify some resources, but it could happen that you reserve less resources than your simulation needs, or in the opposite side, you reserve more resources than what you need. So on HPC2N, we have a very nice tool developed by one of our former colleagues, Magnus Johnson. Yeah. And this tool allows you to see the usage of the resources as the simulation is going, right? So how does it work? Uh, so you saw that with Birgitte. Let me see here. I will clear my screen. You see with Birgitte that in order to submit a script to the queue, you type sbatch and the name of the script. Let's say it's called script.sh. Yeah. And once you do this, you will get a number, right? And we call this number the job ID. So then you can monitor the jobs that are in the queue by typing sq dash dash me. Yeah. And at the moment, I don't have any job in the queue. But if I had one, then I should see here a number below job ID, and this is the job ID of the job. And here you will see the status, which can be pending, PD, the shortcut, or running, it will show an R. And then if it is running, then you will see the time that this has been running. Yeah. And then when you see that the job is running and it started to run, then you can type here on the terminal job usage and the number that you get, something like this, for instance. Yeah. And this will give you a URL. Yeah. Once it starts running, right? So then you can copy this URL and then you go to your local web browser. For instance, in my case, this is my web browser. I create a new tab and paste this URL. And then after some minutes, yeah, you will see the statistics. Yeah. So for instance, in this case, this was a job that required CPUs, and also I allocated some GPUs. And this tool is very nice, yes, because you can see here that the number of CPUs that I allocated are being fully used. You can see here they are being used 100%. So imagine that you allocated 48 CPUs, and then you see that only 10% is being used. Yeah. So then it seems that the simulation is not using the rest, yes, and then you could be wasting some project hours. However, yeah, there are some cases where you will see that the CPU usage is not that good, like 100%. It could be maybe 10% or less than that. But what you are interested in is in the memory. Yeah. Because on Kebnekaise, the memory that you get is the memory per core, right? And you see here that the more cores that I allocate, the more memory I get on the RAM, right, for the CPU. This can be one situation where even though you don't use the 100%, yes, it doesn't matter because you are interested in the memory. Yeah. Or another situation that could occur, right, is that you don't use uh, much of this CPU allocation, but you use the GPUs that are attached to them, right? Because maybe the application that you are using it's fully optimized for GPUs. For instance, if you are running a deep learning model, right, that runs mainly on the GPUs, or if you are using some molecular dynamics code that can run fully on the GPUs like Amber. Yeah? In that case, you won't see much of this usage in the CPU side, but you will see here the usage on the GPUs. So another thing that is not well understood, I think, is the usage of the GPUs. Yeah. Some people can think that by using more GPU cards, then the simulation will run faster and faster and more efficiently. But as you can see here, for this simulation that I ran, some part of the code was running on the CPU side with 100%, right? And also some part was running on the GPUs, but by using only 40%, yes, of the GPU card or of the GPU allocation. So this means that if I use another GPU card, right, the dash dash GPUs that the Birgitte mentioned before, so I won't expect to get a much faster simulation because as you can see here, only 40% was used. Some applications take advantage of the GPU, right? And they can run 100% here. So it suggests that by using an additional GPU, you can get some additional speed up, right? But for this simulation, you can see that 40%, it doesn't matter if I add another GPU card. So it can run a bit faster, but most likely it is enough with the one that I allocated. So you can see that this tool can help you to monitor the resources, right? And to get some optimal values for your simulation. So you have long data productions that will need to do. And this is the first time that you run on Kebnekaise. It would be a good idea if first you run some short simulations and see how this profile looks like. And then for the data production, you launch with more optimal values. Okay. The last point that I want to mention here is reporting the problems with the software, right?
Pedro, there's a question
Yeah, let me see.
in the chat.
How to select the correct GPU card and number of nodes for my number of nodes for my job. So it strongly depends on the application. And if you tell me what application you are using, I can tell you more details. It depends strongly. As I mentioned before, for instance, if you are using some machine learning, deep learning code with Python, most of the time they are optimized to run fully on the GPUs. So then in that case, I recommend to use first one GPU card and monitor how the resources are being used. Yeah. Then you can also take some timing. So monitor how long the simulation takes. Yeah. For a relatively short simulation, maybe 10 minutes, something like that, yeah, that gives you an idea of how the GPUs are being used or the CPUs. Yeah. And then the number of nodes, it's an interesting one because not all the machine learning, deep learning codes are optimized to run on multi GPUs, multi nodes. Yeah. So I have seen several codes in Python, for instance, that mainly use a single node, but they can use several GPU cards on a single node only. GROMACS, a package for molecular dynamics, is one of the codes that can run on multiple nodes and also multiple GPUs. Yeah. And then you can use this plot, right, to see how the GPUs and the CPUs are being used. Notice here that this is the 100% of the CPUs and also the 100% of the GPUs. So imagine that you use two nodes and each node contains two GPUs. Then two nodes will be 100%, right? And collected together, all the GPUs will be 100%. There is an option here, if you see here, this button, which is called all, and then you can click on that, and you will see the details for each individual node. Yeah. So this can help you to monitor the resources, but it strongly depends on the application. Another application, for instance, for molecular dynamics that is called Amber runs only on a single node and it can use multiple GPUs. Yeah. So basically, this is my recommendation. First, start with short simulation, especially if you are running for the first time on Kebnekaise, get some timings, monitor the resources. This is a nice tool that we have, yeah, and it allows you to see the details of your code. Yeah.
Yeah, yeah. Thank you.
Yeah. Okay, so related to this is describing the problems with the software, right? So here I wrote previously that you could write to us through this email address. But now there is a better way to do this. And the way to go is through Super, right? And in Super, if you go to support, right? So then you will see the interface for asking questions, yes, to the different centers. Here you can select, for instance, the type of the problem, right? And here there are some options. For instance, if you have problems running jobs, or requesting the software installation. And I will put, for instance, running jobs. Then you can choose the center specifically for today's course, which is a local course for HPC2N. You can select HPC2N Kebnekaise for the CPUs or Kebnekaise GPUs for the GPU parts. I will choose this one. Yeah. And then you can select the project you are part of. Yes. Here there are some projects I am part of, HPC training instructors, or the one for today. I think it's training courses fall, right? And here there are several categories for the software type and so on. And then you make a summary. And here you describe the problem, right? After this, you can submit the ticket, right? So this is a recommended manner to write us, yes, and create a ticket. But also, if this is the first time that you want to get in touch with us for a problem that you are facing, or you are in a hurry or something like that, yes, you can write to the support email, and then we will get back with some recommendations and solutions. Yeah? So something to consider when you open a ticket, you can describe the problem and the versions of the software that you used. Yeah. Also provide a test case that we can copy or try to try ourselves. Yeah. This can be a reduced example or a real case, and you will need to pack all the relevant files in a folder and write the path to the folder where this example is located. So this is a more um, a complete case, right? Instead of saying, for instance, I have some problem in my simulation and I am getting errors, right? You can first create some example that you can share with us, and then tell us that the path to that folder is there. So notice that we, the application expert, don't have access to your folders, right? For instance, if you have a project on Kebnekaise, myself as an application expert, I cannot simply go to your folder with CD, Proi, no backup, and your project name and see what you are doing, right? So you will need to tell us what is the path, and then there are some administrators that can help us to copy this folder. Yes, and then yes, we can then use this ticket, yes, to reply to this specific issue, yes, or the original issue, yes, for the ticket. So in this sense, you should avoid creating another ticket describing the same issue. Yeah. And also, if you have unrelated issues for the tickets, then you will need to create a new ticket. Otherwise, the things will get entangled, right? if we try to reply or to solve one problem, but at the same time, it is mixed with another problem in the same ticket. So that's why we keep the history clean in the ticket system. So we ask you to use that ticket only for the issue or the original issue. And then for unrelated ones, you can create new tickets. And this is useful for us, right? Once the error is solved, you can just drop a line saying that the error has been solved and that we can close the ticket, because otherwise the ticket can stay in our queue, and we don't know what happens if you couldn't solve the ticket, or if it was solved inefficiently or something like that. So just to get the things clearer, yeah. So you can drop us a line and say that the problem was solved, yeah. Or in another case, that the problem hasn't been solved and it requires more assistance from our side, yeah. Okay, these are some recommendations, yeah, that can help us and help you as well. So then I can go to some particular program that I prepare. Let's try R, right? I like to work with R. It's a software for statistics and, yes, plotting, and it has several features. Yeah. So on Kebnekaise, we have several versions of R, right? And here you can find more information about R, right? In our documentation page. If you go to this button here, yeah. So you will see the documentation for R and more detailed information, right? With examples on how to run this code. Okay, so the first time that you access R, and there are some software that require some initial configuration, and R is one of them. So you will need to follow some preparations, right? So in this link here, you will see the preparations that you need to do with R. Yeah. Specifically, you will need to create this home .r environment, and then you will need to add this line, right? So you go to the home and then create the file r environment, r envir. I did it before, and in my case, it looks like this, rn environ. So if this is the first time that you use that, you can create the file with the command touch, yeah. And in my case, I created that previously, and then I added this line as it is mentioned here. And how to do this? Just copy this line and then execute it in the terminal. Yeah. So basically, we'll paste this content to this file .r environment. This is the configuration file for R, and it helps you to keep track of the different versions of R together with the packages that you start installing by yourself. So by default, the R modules come with some installed packages, but some more specific packages will need to be installed by yourself, right? And depending on the version, you will have a different folder, as you can see here. In my case, I have used some versions of R, like the 4.0.0, 4.0.4, and so on. And inside these folders, yeah, I will have the packages that I already installed. So if you don't do this step, then all the packages that you install will land on the same folder, and this can create some issues, right? Because then the different packages, like in this case, a Biocon Manager, it can be installed on the same folder that corresponded to the version 4.1, and then this package was not supported well for this version. Yeah. So that's why we instruct you to follow these lines the first time, right? And then you can start working with R, and then you can install your own packages for R. Okay, so here I wrote a recommendation in the case of R, right? And this is related to data duplication. So R has several functions to run the code in parallel mode, right? As in this case, I am loading a parallel library, and also this library here allows me to monitor the memory resources that are being used. So here I start to monitor the memory that is being used, right? And I call it previous memory used. And then I paste the memory that is initially allocated by R in megabytes. Yeah. Then I start creating a relatively large data frame. It's not that big, but it's enough for our purposes to show the memory usage. And then once I create the data frame, I do I do some computation. Like in this case, I create a function that takes one value I, and then this value I gets the I row in the data frame, and then it just return the value. Yes, but I multiply it by 2. So this is just a function that performs some operation on the data frame. And after this, I compute the memory that was used, and this is done by calling the memory used function from the package in R, the peer library in R, and they just take the difference that I computed just at the beginning. And this will give me the memory that was allocated by doing this step, right? Then I print the total memory that was used in serial mode. Notice that this is serial mode because this function runs on a single core. It doesn't have any parallel feature. It's a standard function. Yeah? So now let's try another way to run the R code. And this is by using a parallel function in R called MC Lapply. Yeah. And in this case, I define the number of cores. And this in this case is equal to 4. I will use 4 cores. Then I call the function MC Lapply, and I go over the number of rows in the data frame. This will be my iterator. And then notice here that I will execute the function the same that I used previously, right? Here. But in this case, I will be executing this function not by using a single core as in this case, but by using the 4 cores that I allocated. So here I define the number of cores, yes, which is 4 in this case. And after this, I compute the memory that was allocated and print out the memory that was used in parallel mode. So, so in this case, you may think that the total memory was the same for the serial code than in the parallel case, because the data frame was essentially the same, right? I didn't modify the data frame here. But the problem or the situation is that MC Lapply copies the data, yes, so that each of these cores or tasks, yes, have their own data, yes, available. And also in between, it is doing some extra or additional copies of the data, yes, to compute intermediate steps. And that's why when you print out the total memory, then you will see some difference or increase in this parallel execution. Yeah. So then how to deal with this case? So you can copy this script with a memdup, and then use a batch script, as in this case, this example, job.sh. And then you can run the script in this way. This is the name of the R script, and I am using this line to run the R code. So let me try this. In the exercises folder under R, you can see MDOP, and you can see the batch script. Yeah. So this is the batch script that I can use, and I will change the project name to HPC2N 2025 151. It will take less than 10 minutes. I will use 4 cores, and then this is a constraint similar to what Birgitte mentioned for the type of the CPUs. Here is the name of the output file, and this Percentage J is an special variable in Slurm, and this will be substituted by the job ID. Yeah. Also, in the case if the simulation have some errors, they will be written in a separate error file, also identified with the job ID. Here, we recommend to use this line for purging the modules, yes, to make the session clean. So imagine that here in your terminal, you load some modules like another R version, yes, and then when you submit the job with SBatch, and you don't have the module purge, then you could see some conflicts, right? Because the version you loaded on the terminal and the one that is in the script are different. To avoid this situation and to start a clean session in the batch Slurm, we write ml purge, and then we redirect it to the input output and standard error. Then I load the modules for GCC and OpenMPI that are needed for R. So if you are curious, you can search first for the R version with ML Spider R. And then you can see all the versions that are installed, right? I will be targeting this one and to see if it needs to load some dependencies. I type ml spider, the version, and you see that I need to load either this tool chain or this tool chain. I will use this one because my code is not running any CUDA implementation, just a plain CPU code. Then I will use this one. That's why in the job, I am using this, right? Together with the R version. And after this, I will start R with some options for not saving the environment variables and the data that is generating, and I am not restoring from any existing file for the history. And here is the name of the R script. And as I mentioned previously, this should be the same as in this case. Yeah. So you can see here that I need the parallel package and also the peer package. So then I can check first if the packages are already installed in my R version, and if I install it previously. So I type ml spider, and then the version. I will load the tool chain, and I can also load the R version on the same line, right? Or on different lines by using an additional ml module load. Yeah. Then on the command line, I start the R version with capital R. Yeah. And you see that this is a standard R session without the graphical interface. Yeah. So then I can load here or try to load the library parallel. And you see that it doesn't complain, so it should be there. And also the library prior. So it says, well, it is there. Yeah. So it doesn't complain. Otherwise, one will need to install that, right? So I will quit this. And it says, do you want to save the image, workspace image? And I don't save it normally. Yeah. And once we have these preparations, we can submit the job to the queue with SBatch. Now you see the job ID. I can check my jobs with SQ-me. You see that it is running, right? And in this case, you can start checking the usage of the resources with the job dash usage and the job ID. And this is the URL that you should copy and then paste on your local browser. So you will see the details after some minutes if the simulation last more than a few minutes. Otherwise, if it is very fast, you won't see the statistics as in this case, right? Because this was very fast. Yeah. So then we can check the files. You see the error file, if there were some errors, and the output file for the output that the simulation writes itself. Yeah. So let me check the error. So you will see that this was the message from the prior package. Yeah. It's just a message, no error is by itself, right? And then we go to the output and we see the R output. You can see here that the initial memory allocated by R is 26 megabytes, right? Just at the beginning of the R session. Then we define the data frame. Yes. After this, we define a function and computed the function, right? And get the values for the memory. So in this case, the total execution in serial mode required 80.3 megabytes. Yeah. So then we start the parallel simulation, and we use in this case MC-Lapply, which is a function that supports parallelization in R. Yeah. So in this case, we specify the number of cores equal to 4. And if you remember, in the job usage and in the job script, I also specify four tasks, right? So in principle, this is the number that will need to be the same if you are running in parallel mode. And also, it is related to the efficiency of the simulations. For instance, imagine that in this case, right, this is a parallel code, and here you specify 8 tasks, right? but in your R script, you forgot it and specified only 4. So I am talking about this situation. So you targeted or allocated 8 cores or tasks, but in your R script, you are using only 4, right? So essentially, you're wasting 4 cores here. That's why I mentioned that it's useful to run some short simulations and see if the usage is relatively optimal, right? Another situation can occur, right? And imagine that in this case, you allocate one core or one task in this case, but in your R script, you specify 4 cores, right? So it means that you will be oversubscribing the resources, and here you will see a red line going beyond 100%. Yeah. So, and the red line is not good for the system because that simulation will overload the system and the machine will heat up considerably. And most likely we will need to reboot the node, yeah, which is not a desired situation. Yeah. So that's why I mentioned that the job use is a good tool, it's an interesting tool. And I will set this to 4. Let me see. Okay. I will set this to 4. Yeah. And you can see here again in the output, yeah, that instead of the 80 megabytes in the serial case, yeah, when you use 4 cores, you are getting a larger memory allocation, yeah, and actually much larger than 4 times this. This is related to the way that R handles the memory allocation. So in the case of R, so R tries to allocate blocks of memory. So once the size of the block is exceeded, R tries to allocate a larger block size. So it doesn't allocate a memory continuously. So that's why here you observe a larger allocation. So it's a problem in R for data duplication, and you will need to be aware of this, especially if you are dealing with large databases. So in this case, it was not a problem because in the serial mode, this was 80 megabytes, and here is less than 1 gigabyte. But imagine that here you had a 40 or 20 gigabytes, and then here you after doing this parallelization, you go beyond uh, 200 gigabytes. Then you will exceed immediately the RAM of a node, and then simulation will crash most likely. So that's why one needs to pay attention to the resources, right? And this is an instructive example for R. So as you have seen with Brigitte, we also support graphical interfaces in Kebnekaise. And in the case of R, we saw the text interface, yeah, where one can perform the calculations as previously mentioned, like importing the packages, library, parallel, yeah. And this is one way to work. But we also support graphical applications. And in the case of R, the related application or the most related application is RStudio. So you can get it after loading the R version that you target. So in my case, it was the 4.0.4. So then you type on the terminal RStudio. These are just messages from the starting application. And here we get this update message. So we will need to update the RStudio to a newer version. But you can just close this because this is not something that users can do. The administrators will need to do this. Let me close this or not. Ignore update. Yeah. So here you can see that the RStudio is there and one can start working with RStudio as usual on a PC. So I can open my mem.dap example and you can see here the content, yes, that I previously show in text mode. So, and here notice that I can run immediately or straightforwardly the script if I press this button, right? And I go through the script. For instance, if I press run, then it will load the package, then it will load the next, then it can compute the initial memory, print the initial memory, yeah, and then create a data frame and so on. So I can do this, yeah, because these are lightweight tasks. But if you want to go for data production, this is not the way to work with R, right? Because here I am sitting in a login node, yeah, and several people are connected. And if I start running my script directly on the login node, so then the workflows of the other will slow down, and that's not a good thing, right? So this can create problems, especially if you are running parallel code, and this could create the situations where we will need to reboot the node. So that's not the desired situation. Yeah. So that's why instead of doing this, you can do this running the script. For instance, if you just want to visualize a plot or something which is lightweight, doesn't require more than a few seconds, right? But for other calculations, you can write a script, as I mentioned before. This one. And then here you can specify a longer time up to 168 hours, right? This is one way to work with R. And the next way is what Brigitte mentioned with the open on demand, where you can uh, open an application of RStudio, and there you can execute the script directly on the node, because in that case you won't be sitting on the login node, as in this case within link, or within link, yes. But in open on demand, you will be connected directly on a computing node that is reserved for you, and where no other users are occupying the same resources. That's why there you could execute your code directly, yes, with this button here, even if it is not lightweight. But notice that at the moment, Open on Demand has a limitation of, I think it was 12 hours, right? So you cannot reserve more than 12 hours. And if you want to run a longer job than this, then the way to go is by using the old friend, which is a batch script, as in this case. Yeah? And for visualizing the results, for creating the plots, or for doing some extra analysis that doesn't require longer time than 12 hours, then you can start your open on demand and run the simulations there. That's a possibility. Okay, so here there are some exercises that I prepared. This is a serial job. And here is the script that you will need to use. Also, job arrays, if you want to run several simulations or many simulations where some parameter is changed. This is a good option. This one is for running parallel jobs with a package called RMPI in R. Here there is a parallel job which uses the do parallel package in R. And also here I have a machine learning job. Yes, is there any questions about this part? Do you want to see any other software? Or if you have any other question related to this course or to the software that you are using, so let me know.